So the question reads, a coin is projected at an angle of 53 degrees above the horizontal from a point 15 meters above the ground level. It reaches the ground at a horizontal distance of 40 meters from the launch point. Calculate A, the time it is in air, then B, the velocity with which the coin was projected. So what do we have? So basically what we have looks like this. So the point of projection is here. It's 15 meters above. Then you launch the coin at an angle of 53 degrees. The coin goes up, reaches maximum height. Then after reaching maximum height, it comes down. Here passes through B, C. Then the distance, the horizontal distance which the coin travels is 40 meters, which is the range from the point of launch there. Okay, so that's what we know. We do not know. There are certain things we do not know. One, we do not know the velocity with which the coin is thrown up. The launch velocity of the coin, we do not know. We have to find how much time is going to travel in the air. So basically we have to find how much time from here to maximum, then from there all the way up to there. Okay. So that's the bit which we have. However, there are a couple of things we know. The velocity with which the coin goes up here at this launch point and the velocity of the coin here are the same. We also know that going in this particular direction here, they're the same. And from here all the way up to that point, the distance, or vertical distance covered, is 15 meters. So I'm not really sure exactly how we are going to do this, but one way or another we have to try. I'm not quite sure exactly how. Just a minute. So yeah, this is quite a tricky problem. Let's see if there's a way we can use the information which we have. Just a minute. I need to copy some things. Okay. So to proceed, we need to be aware. That the coin is a projectile. As such, moves in two different directions, in two different perpendicular directions at the same time, in the x and y directions. That's the first thing we're supposed to be aware of. Say this coin is moving along the x direction, along the horizontal direction. It's also moving along the y direction. Okay, so this bit we need to be aware of. Next, we need to know how much the initial velocities are in the y and x directions. U is in the, we need to know how much the initial velocity of the coin. We need to know the initial velocity of the coin in the x and y directions. In the x direction, the initial velocity, just a minute. Okay. So in the x direction, the initial velocity, somebody in the microphone, the initial velocity in the x direction, the initial velocity of the coin denoted ux is given by ux is equals to whatever u is, then cos theta like that. However, we know what theta is in this case. Our theta is 53 degrees. Okay? Is that clear? Hello? Yeah, our theta is 53 degrees. So we know that bit. As much as we do not know what the actual velocity is, we know how much theta is. So that could go a long way in helping us. And so that is u cos 53. Okay. And how much is the cos 53 degrees? How much is cos 53 degrees? Cos 53 degrees, how much is it? Sorry? Is it my my volume which is very low or what? You said 0 point what?
0.6.
0.6. 0.6 what? Just 0.6?
0.601.
01. Okay, so that's 0.6. So we have 0.6 u. As our initial velocity 0.6 as our initial velocity in the x direction, so 0.6. Okay, Next, we need to find the. Also, we have to remember that there is no acceleration apart from after we do this. This is something we did last time in comments. Since there is no acceleration, since there is no acceleration in the x direction, the final velocity and initial velocity of the coin in the x direction is the same. So ux is equals to uy, which is equals to 0.6 u. This, or I can say Vx. That. Okay. We also know to say along the horizontal distance, along the horizontal, our from here, from this up there, the distance, the range is 40 meters. Okay, the range is 40 meters. So so we also know that the range of the coin R in the x direction is given by Rx is equals to that. Just a minute. This. The range is equals to whatever ux is multiplied by tf, which is the flight time. Okay. So in our case, our range is 40 meters. Then ux is this 6u multiplied by whatever tf is, which we still don't know at this particular moment. This is just some of the information we can gather from what we have been given. This 40 meters, which is the range, is equals to the ux, which is 0.6 u multiplied by tf, which is what we don't know. So we don't know the u, we do not know the tf. We can divide both sides by 0.6, so we end up with divide both sides by 0.6, end up, and also before I do that, I can drop off the units. Drop off units. We get that. Then divide by 0.6 from both sides. At the moment, there's very little we can do, okay? Because that's what you've been given. From anything we can do in the X, there is very limited stuff. U, then TF. How much is 40 divided by 0.6? How much is 40 divided by 0.6?
6.66.
Hmm?
6.66.
How much?
66.66.
66.6. Okay. 66. My volume is very low. I don't know why. Like what?
Yes, sir. 66.67.
Okay. Okay. So this is basically what this is the information we get from the range. Say 66.67 is equals to U multiplied by TF. We do not know U, we do not know TF. So there are two things which we do not know, U and TF. So we need to do something else so that we can try to figure out what U is supposed to be, so that we can actually find, if we can find what U is, then we can find TF, or whichever one we can find first. I don't think it's going to matter very much. Okay, so we change our approach. Since that's the only thing we can do along the x-axis, we change our approach. We go to the y-axis. Okay, we shift our attention to the y-axis. So in the y-axis, the initial velocity of the coin denoted is given by that. So this is what we get. Uy is equals to U sin theta, like that, in the y. Okay, then we make some substitutions. We'll find out what Uy is. So U is still unknown. We don't know what U is, but we know the other one, the angle, is that. So So we get that uy is equals to u sine this 53. So how much is that? Sine 53? How much is sine 53?
0.8.
0.8.
8.
0.8, just like that?
Yes, it's 0.798. To round off, it's 0.8.
Okay. Open 8. Right. Just a minute. Find something. Just a minute. All right. So next we proceed to work out the motion in the y direction. So there's a part, if you look at the journey of the coin, there's a part where it's moving away from the surface of the earth, then it reaches maximum height. When it reaches maximum height, in the y direction, the velocity at that particular point becomes equals to 0. Okay? So, just a minute. So we consider next we consider the motion. So only the motion of the coin in the y direction Next we need to find, so we need to find the rise time. We need to find the rise time, rise time of the coin to maximum height. Denoted T1. We know that the initial velocity of the coin in the y direction from launch point is this one, 0.8 u. And the final velocity of the coin at maximum height is 0 meters per second. Since the coin is moving away, from the surface of the earth, the acceleration is minus 9.8. Therefore, we can get the rise time. Just a minute. As follows. Try to finish typing this bit. Okay. So the rise time is going to be that way. When you substitute, so you got 0, you got u that. Can we drop off some units? Comment. Just a minute. Here. Forget that. Up to that point. Then that gives us just a minute. Gives us this. Then we can get T1. Now, when we get the T1 here, remember from the previous question we worked out, T1 is equals to T2. Do you remember that? For the same level of height. From here, from the launch point, you go to maximum height, then you come to B here. From the launch point to A, that is T1. From A to B, that is T2. But because the level is the same, T1 is equals to T2. Do you remember that? Hello? I'm not getting a response. Okay, fine. Then we get T1. .8 U. How much is this? 0.8 divided by 9.8. Hello? How much is 0.8 divided by 9.8?
0.08.
0 point? Zero point what?
0.8.
0.8 to U. Like that?
Yes, sir.
Okay. Now that we know the rise time is T is this. We can also work out, we can choose to do a couple of things. We can use this to work out how much is the, I don't know how that's going to work out. How much is the maximum height? Or we can go the quadratic way. I think probably the quadratic way might be much better. So we can get T2. We can get T2, the 4 time back to the launch point, from, we can get T2, which is the 4 time, back to the launch point from maximum height, which is T2. We know from experience as it is equal to T1. T2 is cos of T1. I don't know how this helps us. This bit. From A to B, we know the time from launch to A, then from A to B, then the next time we need to find is from but that's a problem again. If we go along this approach, that gives us, does it give us a problem or not? We know so when here, the velocity at this particular point is the velocity here. The velocity at B, going this direction, is the velocity here. So we know the velocity here. Let me just finish what I was trying to say there. This one here. So this is our T1. Then T1 is equal to T2, which is that same thing. Then we have to find T3. T3 in terms of the other thing. So what do we have? we are at B here, right? We know from the previous example we worked out, say, the velocity at B3, at B here, the velocity at B is the same as the launch velocity upwards, except going downwards. So the launch velocity, we found the launch velocity in the y direction to be 0. What was it? This one in the y direction. This 0.8 u in the y direction going up. That is the same velocity we have at B. So we start off with a velocity of 0.8 at B. Then the distance is 15 meters. Then we're going down. Acceleration is 9.8. Then we're looking for T3. So at point B, which is level with the launch point, the initial velocity, is uy, which is equals to 0.8 u, the height, the depth below the launch point is S is 15 meters. S is 15 meters, and acceleration is A is 9.8 meters per second squared. Except I'm not sure how this thing is going to work out. If it becomes more complicated, we have to work out the height. We have to work out the height in terms of u. If it becomes more complicated, the maximum height in terms of u, then we add the maximum height to the 15, then we work out the other way around, which in my opinion, previously it was much easier. So for that, what do we have? Let's see. So let's see. Comments. So S, you know the S is 15, then UY, then T3, then that 3. Not sure exactly like this. So if we substitute, we have 15 meters. 15 meters, uy of 0.8, u, 8u, then 3, then 9.8, and 3 like that. This. Then if you drop off the units, we got 15. And 8 U T3, then yes, then of course when we, that gives us 15 and 8 U T3 this. Okay, so this is what we get. If you write that properly, get a minus 15 somewhere, equals to 0, then these. Now, if only we knew what U was, things would have been a bit straightforward. But this is a quadratic in terms of T3, and we do not know. You can kind of work it out in terms of U. I think we can try to do that in terms of U. So if you work out the quadratic, it will still be in terms of U. Just a minute. I need to copy something. Where is that? Not this one. The previous one. Okay, I'll copy that. Just a minute. Okay, so here the T3 is like the X, then the other things, the A is the 4.9, then the B is the 0.8 U, then the C is the 15. So we can in this case, we have that's A is 4.9, our B is 0.8 U, then our C is minus 15. Like this here. So this is your A. That's your A. This bit is your B. This is your C. C is minus 15. A is 0.8 U. Then so B is 0.8 U. Then A is 4.9. Like that. So when you work out that one, just a bit. Your B is minus 0.8 U, then plus or minus 0.8 U, now this is going to become difficult to work out. That is my fear. This there. So we can't proceed along this route. So the only other thing we need to do is we need to find, because of the U squared, if the U was a number, fine, it could work out, we could find T3. Okay, but because it's in the quadratic there, then you're subtracting something from something which you don't know, that becomes a problem. Okay, so this root is problematic. I'll write somewhere, say this root is problematic. This root is problematic. So the next thing to do is, in my opinion, we find out the maximum heights. Now we're going to find the maximum height using the following. So alternatively, we get the maximum height the coin rises to as follows. S is equals to 1/2 UY plus U plus VY multiplied by T1. We do this. We're looking for S, but these are things we kind of have got some information about them. UY is 0.8 U. Then VY, velocity at maximum, is 0. Then the time T1, we found T1 to be what? Where is that? is the mistake. That gives us hello, Jonathan. That one is my tutorial. Who's the areas? Okay. And what tutorial? Okay. Then the half times 0.8 u here. So we get 0.4. I think you can see that. So we get the maximum height of above the launch point, above the launch point. The coin rises to as follows. Just a minute. So this gives us 0.4 4u. That. Then 0.4 times 0.08 to how much we get? How much we get? .066 u squared. I don't know if this is going to help us in any way. Like this?
Yes, sir.
Okay. So this is the height above the launch point. From here up to there. That's the height above the launch point. Okay? We already have T1. Then if we want the height, the time it's going to take from A all the way up to C. We need to add this height we have worked out above the launch point. We need to add it to the 15. Now again, how does that help us? That's the issue. That's what I'm failing to see. Let me see. So next, the combined 4 time, we get the combined time of 4. What is TC from the height of 4. The height of 4 is our S is our this which I found 0.66 U2 plus the 15 meters. This as follows. So what do we know? We know S is equals to okay, I think there's hope. S is equals to UY T TC plus the Frank 1/2 ATC C squared. think there's hope. This is the height through which the coin is going to fall through, and the time it's going to take to fall is tc. The acceleration, it's going down, so acceleration is now 9.c. However, the initial velocity of the coin at maximum height in y direction is uy, that is equals to 0 because that's maximum height. So we're starting from maximum height. Meters per second. So substituting. We got the through which it falls, height plus the initial and different 1/2 9.8 meters per second, then tc power 2 okay, but this we drop off the units. Still have a problem. Yes. Then this becomes 0. This becomes 4.9. This still doesn't solve our problem, does it? The problem still remains, except in a different phase. see. Get this. This is a number. If we divide by divide by 9, so we get what? Get this, then divide by 9.9 both sides. We get something, but I kind of don't like what we have. Oh, sorry, there's a square. That's what worries me. What to see? Okay. The 0.066 divided by 4.9 and the 15 divided by 4, how much do you get for that? I think we can stop there a bit. I might need to consult something. If there is a more straightforward way of doing this. How much is the 0.66 divided by 4.9?
0.135.
0.1?
35.
0.66 divided by 4.9.
Yes, 0.135.
Are you sure about that?
Yes, sir.
Let me just check a bit. Zero point zero. Oh, come on. 0.66 divided by 4.9. Oh, okay. 0.013
Yes, sir.
u squared. U squared. Then the 15 divided by 4.9.
3.06.
3.06,
06.
which is equals 3.1. Okay, leave it with that. Okay, then take the square root. I don't think you don't have a lot of choice, huh? Let me see where it goes. Square root on both sides. But I don't like it, let me admit. TC square root that. Okay, that gives us that. Then flight time, FT. Flight time for TF. TF. F is, we have things in the form I don't like. That is T1 plus TC. T1 is, where is that? Then this other guy, like this. Okay. Then recall that. Recall that. We have an expression on top somewhere. Just a minute. Not to begin. We have this. So I don't know if you bring in these bits here, then what happens? It doesn't seem to. That's good. Let's see. These bits. I think you have to end here. It's not making any sense. How do you proceed from here for me? Let me ask the Mr. Shimba if there's a much easier, straightforward way of doing this. Yeah, but it looks like it's supposed to be straightforward, but yeah, let me ask. Let's stop here. Let's continue when you meet on Monday. Okay?
Alright.
Yeah, it doesn't look like we're going to finish. At what so far with what we've done, we keep on getting stuck with all the things we know. Okay? All right. See you on Monday.